Hi, today I will show you a simple example how to simulate a simple case, sand gravity casting using PoligonSoft casting simulation software. And here is the PoligonSoft shell, and here we see some buttons. And in fact, today we will use only this button. It calls master module. It's a preprocessor of PoligonSoft, and we will use Mirage 3D. This is a post-processor of PoligonSoft, and all these buttons we don't use it now because here are some legacy models and we don't use it, but some old customers like to use them. But I think that next version we will delete these buttons because here are some solvers, old solvers, and now we use new ones which we can start from preprocessor model. So I press master button and we will see preprocessor of PoligonSoft. Here are some tree, some working area, and all commands we can see here. A lot of buttons and menu, which is duplicate these commands. So I will open geometry file. Geometry means mesh. It's not a CAD geometry with the surfaces and so on, but it's a prepared mesh. I will not show how to prepare mesh today, and I will use some mesh that was generated in mesh generator from Altair Hypermesh. So I press this button, and here I can select type of file, and I can select Hypermesh and choose units. And I know that Hypermesh use millimeters, so I can select it, press OK, and go to PoligonSoft folder here, tutorial, yes. And here are some files. They're Hypermesh formatted. For example, I will use this one. And mesh is loaded, and I see a question. Do you want to save previous simulation parameters? PoligonSoft can save previous session, and if you load new mesh without any casting parameters, you can use previous ones, but now I will press no, because I want to show you how to set up case from zero level. No. And here we see two positions, two volumes, and one mesh. The first mesh from file is a casting as default, and all other meshes from file are mold as default. And if I will use this one checkbox, I can turn on and turn off visualization of these volumes. So here is a visualization mode panel, and I can visualize and I can show all volumes as I want, with the mesh or without mesh, with mesh nodes or without mesh nodes, with section. As default, I see section in XY plane, and I can see this contour of section. And the same buttons for mold volumes. For example, I can show you mesh, nodes, section, and so on. And at the beginning of this case setup, I will use this button. It calls Start Simulation Parameters. And here we can enter all necessary parameters for our case. Here is a general tab, and here we can use alloy temperature, mold temperature, and environment temperature. For example, we will simulate steel gravity sand casting, and I will use alloy temperature 1580. And mold temperature is 20 degrees, and air temperature is 20 degrees. as default. And here is a next string, alloy data file. It's alloy properties, and I can make double click and use this small button and choose some material from PoligonSoft database. To see it, I will go to PoligonSoft folder, and here is a BD folder. And here I see some other folders and steel. And here I can select some steel. In fact, here are Russian steels, and here we can see some European or American or German analog names. For example, I will use this GS45 steel. I select it, and here I see path to this file. And if I will make a double click and click edit button, I can see this editor of alloy properties. And here we see which properties we use. If we see here one number in value column, it means that we use constant property. For example, density is a constant and heat capacity is a constant, but heat conduction is a curve. I can make a double click on this string and show this curve, and here I can edit it or move points on the curve with my mouse, and so on. Here's a heat solidification, and these two lines is one curve. It calls fraction of solid. If I will make a double click on this string, or here we see the same curve, it's a fraction solid curve, and here is a liquidus temperature, and here is solidus temperature, and fraction of solid. So here is a properties, alloy properties only for temperature calculation, but if we want to to simulate porosity, we need to set up alloy properties for porosity simulation on other tab. I will show it later. So I will close it. And here are some three strings, three rows in this table. Here we can set up technology. And in PoligonSoft, we have some templates of technology, some foundry processes, and I will show how it works. For example, mold data file, what is it? It's some package of materials that engineer usually use in its foundry. For example, if we talk about the sand casting process, it's some, for example, it's a sand mold, it's some chills, for example, it's some insulation and exothermic sleeve, and we can pack all these materials in one package and use it every day, and don't set up materials for every case. So I will make double click here, show this button, and in BD folder in PoligonSoft I see these templates, and here we have die casting templates, high pressure die casting, God casting, investment, and here I see sand casting. I select it and press open. And the same for heat transfer data file. I can select some template, and I will find it here in BD folder, sand casting. Yes. And if I need to set up some special temperature modes, for example, my mold temperature is not constant and some volumes have other temperatures, I can set up these temperature prediction temperature files. And we have this file for sand casting too, but now I don't need it. So let's look at this mold file, mold data file, to see what is it. I will press edit button, and here is some editor, and we see here 9 regions and 9 materials, and every region it's some material. Here we see name of the material, and region 1 not specified. There's no material here. And for example, region 2 sand mold alpha set process, region 3 sand mold simple sand mold. Here's a chromite sand, chill iron, some special melted chills, steel chill, and so on. And here we can see properties for every material. We use heat capacity and heat conduction. If you want to edit this package, you can do it. For example, you can change this position. You don't need the melted chill, but you want to use some insulation material. So you can press right button mouse here and load new material from base. And here you see some materials, and you can select something, for example, some material from analog of Faseco material. Press OK, and here it is, new data for this material. And then you can save as, don't save it now because you will overwrite system template, but you can save as with your name and use this template later with your process. If you can't find some material here, you can input it by yourself. So you can create, any material with your name, press enter, and then edit this this curve. Here are 10 points, and you can edit them, for example, and so on. You can do it like this, or you can load constant, for example, like this, or you can make line from this point to this point. Click here by right mouse button, here 1 point and here 2nd point, and press line, and you will show this result. So it's some package of materials that you use every day in your simulations. Now I will not save anything. I will close it. And what about heat transfer data file? What is inside it? I will press edit button, and here we see some regions too, not 9 but 18 regions. Every region is some part of boundary of casting or of mold, and it can be a boundary between casting and mold, or between casting and chill, or between casting and environment, and so on. But every region is some part of boundary, and for this boundary we can area we can specify some heat transfer conditions. If its boundary is inside, if it is an interface between casting and mold, we can set here heat transfer, for example, beta 1, and the beta 2 is the same heat transfer, but we can use it for convection, for example. So as default, this region number 1 is used for casting sand mold interface, and here is a heat transfer coefficient 500 watts, and here is a S1 parameter. It means that all interface between casting and mold will be used with this coefficient. It's too difficult to understand, I think now, but later you will understand how it works. And if we will see last 2 regions, we can see that here are some settings. Region 17, casting environment interface. So it's external boundary between casting and air, and here's convection and radiation. And so these two parameters, S1 and S3 turn on. So this works and this works. And S2 shows that this parameter beta 2 is turned off. And this region 18, it's a sand mold environment condition. And here we see convection and radiation too. Now I will close it and I will show you how it works on this mesh. First of all, I need to set right position of this geometry. In PoligonSoft, gravity vector is opposite y-axis. So this button, reset rotation, I will press it, and here's the right position of coordinate system. And if I will turn off mode, I will see that my casting is upside down, and I need to rotate it around X to set right position. Don't use mouse now, but use these buttons and rotate this mesh around X axis 1 and 2. So now this position is right, but I see that coordinate system is not right now, but now I can use this fixed rotation button for recalculation of all coordinates. I will press it. And now I see my casting in right position and coordinate system in right position too, because all coordinates of mesh nodes were recalculated in right position. So now I see that it's okay, and gravity force has a right direction. Now I need to set up materials. I made it for alloy for casting. Here it is. And what about mold? Here I have a package with 9 materials. What materials I will use here? If I will make double click, I will see volume parameters window and dialog, and here I can enter name for my mold, for example, sand mold. Here I can set up type of volume, and there are 2 types of volume we use, casting and mold. In casting we simulate temperature, porosity, and other fields, and in mold we simulate most often we simulate only temperature fields and sometimes stresses, but never porosity, never solidification. Because so this is very important to set up right volume types. And here we can select material for mold. If I will set up here casting here, I will see here no named indexes or names because we can't set up material for casting here. We set up it in table, but for mold we can do it. So here you can see volume index group, because every volume or every mesh in PoligonSoft has its own volume index. Volume index means material for mold volumes, and it means some conditions, for example, temperature modes and some other conditions for all volumes. So when I select this volume index, I choose material, and in other dialogues I choose some conditions, special conditions. And here every volume index has its own color, and if you see such color, you can know what material we use here. Because if you use this template every day, you will know what material you use looking on this color. So for example, I will use simple sand mold, and I will press OK, and I change this color. But to see these colors, volume index colors, I need to select a special visualization mode in this toolbar, and it calls index mode. Now it is turned on, and here are some other modes, for example, type mode, and here I see what volumes are in casting group and what modes are in mold groups, because casting volumes are red and mold volumes are blue. And in this mode I see index volumes, so I can see what material I use for my mold. So I made this settings, and the last one is heat transfer, and here we use this third borders mode. If I will press it, I will see other colors, and now I will show you editor of heat transfer data. And you see that this pink color is a boundary between casting and sand mode, and here we see it. So if we will turn off casting, we see this boundary color inside. If we will turn off mold, you will see this pink boundary. And it's a default boundary, and PoligonSoft finds interface between casting and mold, and automatically set this boundary number 1 here. And so it's very useful to set up heat transfer coefficient between casting and mold for region number 1, because it's a default boundary. This gray color means section, means nothing. It's some inside. But here outside we see this blue color and this light blue and this light red color. And in our heat transfer package, we see that these colors means external boundary for mold and then external boundary for casting. And these two boundaries, they are default boundaries too, and Polygon automatically set this to the model. It's very fast case setup because I don't need to select some of these interfaces and to set up these coefficients and so on. Most things will be made automatically. So what are the data we can set up here? Thread count. You can use all CPU cores. So if you have AMD, for example, with 8 cores, you can select here 8 cores. My Intel Core i7 has only 4 cores, so I will set up 4 cores. Now we can set up filling parameters, and here we need to select the place, some area for inlet. And here we have a special tool. It calls Inlet. I will press it, and I press plus button to create new inlet. You can create 8 inlets for each geometry, and so you can set up some difficult situations. For example, the first inlet to the sprue and the other inlet to the riser, and so on. And you can set up logic and turn-on conditions and turn-off conditions for each inlet. Here we'll have only one inlet, and I will press Control button on my keyboard and will click with the left button here. And here is some circle, and this is an inlet area. If you want to set up it, you can press Control button and click here for right position. Or if you have some good mesh here, you can snap the center of the circle to grid node. Check this button and click, and you will see the result. Here is a diameter of my inlet, and for example, I want to make it 30 millimeters. And it's very important. This area is not dependent from mesh, because we simulate temperature and porosity and stresses with finite element mesh, and we simulate filling with finite difference mesh. So we can have big elements here, and we can have a small inlet, and it doesn't matter. So diameter 30 millimeters, and turn-on condition is the time. I can select turn-on condition here. Now it's time, 0 seconds. I will fill this mold from the beginning of the process, and turn-off condition, this inlet will be turned off when filled percentage will be 100. And the whole stop of flow solver will be when inlet number 1 will be turned off. It's the most useful situation, and this dialog, it was set automatically. So I will press OK, and my inlet is ready. Go to Start Simulation Parameters, go to Flow tab, and here I enable turn on my flow solver. And here is some special option, Save Simulation Time. Because I use finite difference method, I will use some cell size. I will use some different cells, and I need to set up its size. And for example, I will use, let's be 3 millimeters cells, and if I have a large mold, that means that there will be a great amount of these cells. And I can save simulation time if I will simulate temperature field not in whole mold, because this process of filling is fast. It's some seconds, and it's a fact that mold will be heat in only in some layer here, but not all mold will be heat. So I can use this option to simulate temperature not in whole mold, but only part of mold. And this part of mold is based on dimensions of casting volume. So I will simulate mold temperature in this area. Result output steps, it's 0.22 seconds by default, but I prefer 0.1 second. Inlet velocity file, I will use it from database. It's a velocity curve, and I will make double click here and press this button and go to BD folder, and here I see some velocity profiles. These velocity profiles with constant velocity for small ladles, and for big ladles we can use curve velocity profiles. For example, here there is 2 tones ladle, and if I will press edit, I use that for my inlet number 1. And if you remember this color, and it's inlet number 1, here I see my velocity curve. And if I will select this profile, for example, here is a constant velocity, and you can edit this table or edit it here, and you can save it to your folder as your own profile if you can't find something useful in BD folder. And here you can set up all other 9 velocity profiles if you use more than one inlet. So here is a string for initial mold temperature. If you simulated some mold heating, you can use this field, but we don't use it. And here are some 2 parameters that I will not change. And go to solidification tab. Here I see enable solidification module is turned on, yes. Output cast results, yes. Output mode results, yes. Solver time step, here I can select it, and 1 second is a very good variant. And the output time step is 10 seconds. You can set here something you want. It's a time step for write solidification results, and 10 seconds is a good value to have not such big files. But sometimes if you simulate high pressure die casting, you need to set up here small parameter, for example 0.5 seconds or something else. Initial time is not 0 seconds, it doesn't matter. And simulation stop condition. Here is a stop condition. T-sol, it means temperature of solidus temperature. So when all casting will be solidified, simulation will be turned off. You can double click here, and you can select some other condition, for example end time and end temperature. If you will select end time, you need to set up this parameter, and if you want to stop simulation using this t-end, you need to simulate end temperature. But now I use solidus temperature as a stop parameter, and it doesn't matter what we see here. Here is a parameter, use initial temperatures from flow results, when flow simulation will be stopped, or results from differences mesh will be transported to our finite element mesh automatically. And here are some other conditions, and I will not use them now. So I go to Porosity tab, and here macro porosity model turned on, micro porosity model turned on, and this row use new micro porosity and new micro porosity model. It's a new model, and now we will not use it, but it's very useful when we simulate some castings with risers that are inside mold and have no this outside area. Right porosity results, yes, and right pressure results, no, because we usually don't use it. So here is some atmosphere pressure and alloy data file, and here I need to go to BD folder, steel, and find my JS45. And here we can see what data is inside, and here we see some properties and parameters of porosity model that we use. But now I will not speak about them, so I will close it. And stress tab and stress model is turned off, and it's okay now. So I can start simulation. I will press simulation button. I can select or create a folder for my project. For example, sand casting, and here I can select name for my project, or I can use this default name. So when I will save it, all files, for example, a load data file and mold package and heat transfer package, so all templates of my process will be saved here in data folder. So later I can copy this project file and this data folder to my USB flash card and go to other computer and run simulation there and so. So now I will press button and simulation starts. Now you see simulating filling now, and I have finite difference mesh. Here is a number of meshes, and here are iterations of my simulation, and here I see simulated time T and percentage of filled material and percentage of solidified material. Yes, now we see that time is 0.339, and our save time is 0.1 second. So now I can show you some results, and I will start Mirage 3D model from PoligonSoft shell, or I can start it from this button. And here is a Mirage 3D. And here is I can load a hydrodynamic file. It contains velocity field, or I can load temperature field from the same file. So I press load velocity field, and I see this file. And if I will press load temperature field, I will see the same file. So there are two fields in one file. And here I can press show model tree button, and I will turn off mold. And here is some gray color. I don't like it, and I can change background color here. Click on this rectangle and select white color, for example. And when I change anything here, for example, I want to change this scale, and I can select other color shim from this list. for example, like this. When I change here anything, I need to press this big apply button. So now I see my white background, and here I see some part of liquid metal. It's inlet, and I can turn off, for example, show edges or show transparent casting. And here's a player toolbar, and I can press this button to move next step or move a few steps, and as default it's 5 steps forward, and to move to the last step, so we can see how it looks. We don't see a stream here, and this is a visualization error because our finite element mesh is too big. So I can make it much better if I will use this button split elements, and I can split elements in all area or in selected area, and then I will see this stream much better, but I will not do it now. So we can see on velocities, and here we see some gradient colors. If we can turn off it and see colors as here. There are 10 colors in scale, and I can press make double click with my left mouse button to see velocity value everywhere, a lot of points, and with the right button, double click right button, I will turn off points, and I can edit this scale. For example, my start velocity is 0.8, and I can make maximum velocity here 1 meter per second, and these checkboxes, they fix values here, and if I will turn off some checkboxes, I will enter 1 meter per second here and press enter, I will have a distribution of velocities between two checkboxes. So it's better to have something like this here. For example. And so we can wait to the end of simulation. So our simulation is finished, and here you see the place when filling solver finished simulation, and here is a simulating certification began, and here we see save result, time step every 10 seconds, and here is total simulation finished. So I can press any key and close this window, and here we see how filling process is looks like. For example, I can use outer button. So this defects, it's not a defect, it's only very coarse mesh. It's a defect of translation from finite difference mesh to finite element mesh, and some defect of visualization. Here we can see velocities, and for example, section of casting and velocities inside casting. And also we can look at temperature field during filling in the same file with the FLV extension. And here I can set another scale, color scale, and I know initial temperature, it is 1580, and I see liquidus temperature, I can put it here, and for example solidus temperature, and apply all this white background and apply all the settings, so I can look in temperature field to see how temperature of liquid metal changes. Maybe without mold. So you see that we have some temperature field here, different temperatures, but they're too closer to initial temperature. So when filling was finished, certification solver and porosity solver started, and we can analyze temperature fields during solidification. This file with solid at the end of the name. And here we can use default scale. I can press this button with 0, and you can see that here we can use a percentage of liquid or solid fraction from 100 of liquid to 0 liquid. Here is the solid state, and here are some temperatures lower than solidus. And if we will use this outer viewer, you can see how temperature changed outside casting, on the surface of casting, and inside of casting, for example. And now you will see how hotspot was created. Here it is. So the another way to analyze temperature field is a surface. Surface, the special mode, visualization mode, when we can show only some isosurface and all parts and all temperatures below or higher than this isosurface. For example, if we will set 0 liquid isosurface and will show isosurface and temperature that higher than this isosurface, like this, and I will switch on transparent cast. So we will see only those parts of casting with liquid metal inside. For example, it looks like this. And here transparent areas, they are solid. They are solid, and we can analyze what spots and their movement. For example, you can see it here. And then some critical situation here. Also, we can switch this button display pipes, and during solidification we will see how level of liquid metal goes down, because we have change of density and so more realistic picture. But what about porosity? We can analyze porosity using this button, open porosity file, and here it is. And here I can set white background and some other scale. And here I go to the last step and see this is a pipe in black. I think that 50% of emptiness of porosity and 10% porosity, it's a pipes too, but smaller than this one. And inside we see this situation, porosity area. So you can analyze your simulations in this way. Okay, I think it's enough for the first time, but I will wait for your response. Do you like such videos?